Hello, welcome back to the third video of the series. We're going to go ahead and take what we discussed in the second video and take that a little bit further. Extend the discussion about the K-build system into how that relates to building external modules. And we're also going to go ahead and take advantage of the fact that we used the menu config system to enable debugging in the kernel to go ahead and show how you would actually do kernel debugging on a module, which, if you're at all familiar with debugging loadable libraries in GDB, it's very similar to the same concept. The same idea applies. So with that, let's go ahead and look. This is just a very simple external module. I'll go ahead and include the source for the makefile and the .c file with the video. Let's go ahead and take a look at that makefile, and what you're going to see is that there's a lot of aspects of this that look very similar to the in-kernel tree makefiles. We have this obj-m, where it's simply just hard coding that we want to build this as a module. Here are some convenience variables, which actually I'm going to be overriding a few of these because I'm not building for x86-64. That's what the question mark equals in GNU Make is. If you're unfamiliar, it's a soft assignment of the value. And here are some traditional GNU Make rules, which this is a difference between the in-tree kernel module or kernel makefiles and the external kernel module. Fundamentally, what this is doing is telling make, we're calling make to go ahead and consider this file, and we're basically spawning a sub make to consider this -c basically says go ahead and switch over to this particular directory and use this as the basis for considering make files, things like that. So what this is actually going to do is pull in the GNU Make, or I'm sorry, the kernel K-build system, which will define a bunch of rules and also bring in the kernel configuration for the your kernel that you're going to be using. And then this this m variable will direct the kernel K-build system to come back here and build an out-of-tree kernel module. Let's see here some of just the other settings. Verbosity, how much does it tell you about what's going on during the build process, and cross-compile, what cross-compile toolchain to use. And just to wrap it up, we're just telling the K-build system only consider modules, don't try to build additional stuff. Clean, it's basically the same arguments, it just directs it to clean up the the generated object files and some of the other things that come out of the kernel build process for modules. Okay, so let's go ahead and, as I said, I'm just going to attach the .c file. I'm not going to cover that in this video. Let's see here, because in all honesty, there's not a whole lot of value in covering that in a video, and as I said, this is just a series of videos to talk over how to work with the kernel and how to debug the kernel on NI targets, not necessarily how to write kernel code. Okay, so as I said, I'm going to go ahead and overwrite some of those variables. Let's see here, make, and it's bm arch equals arm. That's basically going to override the convenience variable in the make file. bm cross compile is equal to home brad 64 sysroots, SDK, user bin, okay, and let's see here, BMKS is home, Brad, Linux, this directory that we were using in the previous video, and we'll leave it verbose, so we'll just go ahead and do that. Okay. It is relatively quick. You can see that there's a bunch of generated files. Basically, I'm not going to discuss these. If there's interest, leave a comment, and I can talk through what all of these are. But they're also just, you can find out about them online. It's documented fairly well online. All right. So let's go ahead and copy over the .ko, which is the actual loadable module, over to the controller. Okay. Now on the controller, you can see that we have this ni-no-op.ko. I can go ahead, if you are somewhat familiar with Linux, you may want to try to do a mod probe. That's not going to work in this case, not yet. It's because it's actually not in the normal place where kernel modules are stored. So for the time being, we're just going to use this insmod command, ni-no-op.ko, and you can see that if we look at the modules, we can see ni-no-op is loaded. Now, as I may have mentioned, I believe that I've written a bug into this kernel module. So let's go ahead and this is a kernel that has the KGDB and KDB system enabled, which we showed last video. What this is going to show is that if there's a particular problem in the kernel, it will actually break into the KDB system in the case where both KGDB and KDB is enabled. So if we go ahead and attempt to read from dev ni-no-op, what's going to happen is, oops, we see that there was a pretty big issue. Oh, I forgot to actually enable the actual KGDB system. So right now, anytime that you have an oops that doesn't cause a panic, you should still go ahead and reboot the target, just because you're unsure if things have gone wrong in the system, if things have been mangled or internal data structures are problematic. So I'm rebooting the target just to show that this, if you're doing kernel development and this happens, you essentially should just stop whatever it is you're doing and just reboot the target, because you can't guarantee that things are going to be good anymore. Things are going to be sane. So, okay, finished rebooting. Now. Come on. Alright. So we'll log in. We will go ahead and enable the KGDB system. GDY 05260. We will echo that to sys module KGDB over console parameters KGDB over console. Okay, now we have registered the kernel debugging system. So now let's go ahead and insmod the problematic module again. So let's try that again. So we will go ahead and try to read from dev ni no-op. Oop, and we panic. Oops, I'm sorry. And we get a backtrace. And we covered some of the ideas of how to work with KDB in the previous video. So for this one, I'm just going to go ahead and just switch it over to KGDB mode. Okay. Detach from the console. And let's go ahead and start GDB. Target to L32. Little harm. What we're doing is just telling GDB, hey, use this for considering the target of what's being debugged. And now what we'll go ahead and do is connect to the target. TTY ESB 0. Again, kernel side, when enabling KGDB, you point it to what the serial port is for use on the target. On the remote side, on the host side, you basically tell it the serial port on your debugging machine, your laptop, your computer, your desktop, whatever. Okay. And we can see that unfortunately we don't know where exactly we are, and that is an artifact of the fact that we don't have the symbols loaded for the kernel module. So what we can actually do is in GDB and KGDB, there's this notion of monitor, which I think we covered briefly in the previous one, but what we can go ahead and do is in KDB there is a built-in command lsmod which will tell us the offsets for all of the modules that are loaded, and ni no-op is actually the one that we care about, and we actually care about not the module structure but the actual location in memory. I also have a built-in that I put together. It's basically gives us the same information, just in a more compact form. I just found it online. It's a pretty useful GDB function that you can define in your GDB init file, which is a nice way to preload some of the functionality and availability of functions and setting variables the way that you want it to be set. Alright, so let's go ahead and for those of you who are familiar with it, we're basically going to use the same mechanism that you would use for loading a library's symbols during debugging. So we add symbol file, we tell it where to find that symbol file, or the file to use, which is work get tech demos ni no-op module ni no-op.ko, and we want that at the address provided by both the monitor KDB call for lsmod, as well as my own little built-in for lsmod. Okay. Yes, we want to add that. And now if we do a backtrace, we actually see symbol information instead of question marks, which is what we saw previously. We're at address, BF 20E1B8 in, I don't know. We actually now have information about where we are. Same offset, and now we know that it is in NI_NO_OP read. And as an additional bit of information compared to what we had before in terms of just offsets, we actually have line number. So we are at homebrad, basically the NI_NO_OP.c file at line 72. And if we use the GDB directory to go ahead and set directories for considering source files, we actually can get access to the I see. Alright, well, basically you can use that to help debugging and showing the source that you're debugging. But for the time being, let's just go ahead and take a look at the NI_NO_OP.c file. Okay, line 72. So we can see that there's this pointer variable that's an integer pointer and it's a null pointer, and we attempt to dereference and increment. So clearly that's incorrect. So let's go ahead and delete this line and clean up that variable that we're not using anymore. Okay. Now what we can actually do is continue execution. Actually, let's just detach. And I think unfortunately with the GDB system, oh no, it does continue, but because the operation that happens is not overly problematic, we could just continue, but again, as I said, let's just follow best practices, and it caught the attempt to increment null pointer dereferencing the value at address 0. So technically it should be fine, but let's just err on the side of caution and reboot. So while that's going on, let's go ahead and clean, which you will see will remove all of that stuff. And let's see here. Yeah, okay. Just wanted to double check that I wrote that out and didn't just not save the fix that I'd done. Alright. So let's go ahead and build the kernel module. Okay. Copy it over to the controller. And here what we're actually going to do is we will move the NI_NO_OP.ko to live with the rest of the modules for this particular kernel. Kernel drivers. Okay. Now we go ahead and run a depmod. What that does is just build some kernel module bookkeeping information, and now we can go ahead and do that mod probe that you may be familiar with. we see that indeed NI-NO-OP is loaded. And now, fingers crossed, we can actually read from dev NI-NO-OP. Oops. Hope if I got the right path. And hey, look at that. So let's go ahead and take this a little bit further. Let's go ahead and enable the let's see here. Let's see here. I think it's symbol file to discard. Yeah. Okay. You know what? Actually, let's just, that should discard the symbol file stuff, but I'm just going to be sure here. Let's see here. Set target 32 on. Okay. We will go ahead and oh, we don't know the offset yet. Another way that you can actually get kernel module offset information is actually looking at that sys modules KGDB. No, not that one. NI-NO-OP. And you can see that there's actually a sections folder that has the .bss, .data, all that kind of stuff. And what we care about is the text. And we can see that actually, I don't think it's the same location, but it may be, I'm not sure. But anyway, what we can do is enable the KGDB system, so TTY S0 15200 to sys module KGDB over console parameters KGDB over console enabled. Let's see here. Now let's go ahead and trigger a break. This was covered in the second video series. Okay, let's see here. So it was BF20. So if we do an ls mod, we can see that it actually matches what we were able to pull out of the sys file system, virtual file system, for that particular module. So that's three different ways that we can get it. Either the KDB monitor, a kind of helper script that basically looks at the module structures, and through a live running system, although with that you need to, be a little bit mindful that you are going to want kernel module offset information. So it is better if you have a system that you expect will break into a kernel debugger to have either the KDB monitor available so you can get module offset information, or one of the built-ins. Of course, since the built-in is doing nothing more than looking at kernel structures, you are able to actually manually figure that information out on your own after the fact, but you're basically crawling through internal kernel structures to figure out what that offset is. So let's see here. Let's go ahead and add symbol file or git NI-NO-OP.ko. The reason that we are reloading all of this debugging information is because the kernel module itself actually changed when we fixed it. So we don't want to be using stale symbol information or code information. Offsets will be wrong and you're going to have a bad time. So now we're broken into KDB. We switch it over to KGDB mode, detach the serial console, target, remote, dev, tty, USB 0. Okay. Now let's go ahead and set a breakpoint. We're just going to go ahead and break on, let's say we care about NI no op, and it provides tab completion. And so if you've never used GDB before, it may seem a little bit intimidating at first, but it provides tab completion and a pretty robust set of help topics for all of the different commands and functions and features that you would care to use. So that's, I would say, don't necessarily just be put off by the complexity or the seeming complexity of working with GDB. It provides a lot of ways to make you more efficient if you just take the time to become familiar with it. So let's go ahead and step off of my soapbox and set a breakpoint at NI no op right. Okay, so let's set a breakpoint. Let's go ahead and continue execution. And let's go ahead and SSH to the target. And the reason that I'm not using the serial console is because, as I mentioned before when talking about debugging, you can't necessarily have two things using the serial port at the same time. So now if I go ahead and attempt to write to the module, to the device, what you're going to see is that it actually breaks in at the GDB console. If I do a backtrace, other than all of that stuff talking about not being able to find some Python stuff, which would happen if I actually installed the GDB that I built into my system, but I'm not going to do that. You can see that we have some of the structure information. We actually can see what it is that we're trying to write to the actual file. And let's see here, let's try this again. Work, contact, demos, no op module. Okay. Alright, so this time it seems like it's working. I'm not quite sure what I did the previous time. I guess it was, it's complaining that it was a built-in, but it wasn't. That stack frame wasn't really, I don't know, whatever. So we could actually take a look at the code at the breakpoint, and we can see that actually in the backtrace itself we have access to the buffer we wanted to take a look at. Basically, we can see that this particular file operation is just not going to do anything. It's going to return an error invalid and print to the kernel log. Just for those of you Ren and Stimpy fans, Mr. Horse comment. So let's just go ahead and continue executing, and we'll see the SSH will pick back up and tell us that, hey, it's an invalid argument. And furthermore, if we look at the kernel log, you see the print K. So that concludes this session, just going over how to build an external kernel module and load it into the kernel, and how to actually debug stuff. Let me take this opportunity to once again just really heartily recommend that if you are tempted to use an out-of-tree kernel module when there's a perfectly valid, perfectly good in-tree kernel module, you are setting yourself up for quite a bit of pain in the future, just when that module no longer works. And basically, there are very few good reasons to use an out-of-tree kernel module when there's an equivalent in-tree kernel module available for you to use. And don't just take my word for it. You just do a little bit of research and you'll see that I'm not alone on that. So I'll just leave it at that. As I said, I'll go ahead and attach the source that I used for the out-of-tree kernel module on the page where I linked to the video, this video. And if there's anything else that you guys would want me to cover in these, go ahead and leave a comment asking about it, or open a question or a discussion in the community forums, because I'm probably just going to skip the actual NI week presentation. I did a demonstration using a USB sound card, which enables just some external piece of hardware. Really, that's no different than in the second video where I enabled KGDB and basically kernel debugging. Really, at that point, it's just a matter of figuring out what it is that needs to be enabled, enabling it, building the kernel, putting it on your target. So I'm just going to skip that one unless there's a huge outcry for covering that demo as well. With that, hope you enjoyed the video, and leave comments if you have questions.